In this video, I'm going to be doing a preventive maintenance servicing on this Tektronix 2235 analog oscilloscope. It does work 100%, but I want to go ahead and check for reefer caps, and sure enough, I found two in the line filter area, which is typically where you find XY capacitors at and so forth. And then you got to look around the power supply too. You'll find them typically on the primary side. If you see them, replace them. That's one justification I could say. It's okay just to shotgun and replace the capacitors, because if those fail, and which they will, because unfortunately I use this epoxy casing, and I'll pull one out when I desolder and get it completely out, but they use that epoxy casing which cracks over time, and it goes ahead and absorbs moisture and stuff, the paper that's inside and stuff. And what happens is they tend to dead short, and when they dead short, they burn up, and they also leave a nasty smell. So anytime I see this style of reefer capacitor in there, I just replace pretty much all the time. The same thing even with the actual line filters and stuff. They got capacitors in there and there happen to be reefer, change them out as well, and you can find usually a suitable replacement through DigiKey and Mauser and stuff like that. That will fit right into there and stuff like that. But I'm going to go ahead and replace these two for now, because I do got those on hand, because I always keep spared, and these ironically are reefers too, but thankfully they went ahead and now they manufactured them better. So that's what's going to go in there. And then the next thing I want to do too, which I was checking for to see if I saw any like shiny spots, looks like liquid oozing out of the capacitors or anything right off the back, just to give a glance, pretty much, you know, glance over everything and stuff like that and see if those capacitors are in good shape or not. Typically when these go bad, usually you'll see dark spots along here, which I see on a lot of Tektronix scope. When they start to leak, and they usually leave a shiny residue around them and stuff like that. If you do, even if they test good, just replace them. Fortunately for me, these actually look fine. They don't look bad at all. And like I said, the scope doesn't have very many hours, so it's likely why they're still good. But they don't show any sign of leakage or anything like that. But I'll go ahead and put an ESR meter and just go ahead and test them and stuff. I may down the road replace them anyway, but for now they're working. Once I see what the ESR reading, if I see any bad ESR, then I'll replace them right off the back if I have them. But for now, I just want to get those reefer caps out of this line filter assembly and then replace a new one, and I'll show you it once I get it out completely. So went ahead and removed the reefers. I went ahead and already replaced it. I got the line filter back in there, but as you can see, these are pregnant and we're ready to pop. So I'm glad I went ahead and took care of it, because these definitely would have left a smell and they would have shorted pretty much. But you can see in there that, yeah, moisture definitely has gone in there over time and stuff like that. And of course, being the fact that they're bulged out. So yeah, I'm glad those came out. And thank goodness I decided to go ahead and check the capacitors on the power supply, because sure enough, I found a couple bad ones. And I'm going to go ahead and replace all these silver ones, because they're kind of suspect. You can see there that's measuring higher ESR, because they should be spec'd at about 0.44 or so for ohms, and it should be reading around 840 microvarads, give or take 10%. And this is measuring way higher than what it's spec'd, and that's a bad thing actually. You can see there, right there, 840 microvarads, and it's measuring 1330, so that capacitor is shot. The other two are starting to fail as well, but not as badly. They're a little bit out of spec, but they're not that bad. But I'm going to go ahead and replace all those silver ones, because they are testing kind of off. So that shows you pretty much what a bad capacitor is. And that's how they test on an ESR meter. On an LCR meter, you can change the frequency, of course, and stuff like that, and then be able to get a more accurate test out of it. But either way it goes, this one here is testing bad, so it got to go. And typically when a capacitor measures higher value than what its actual rated capacity is, especially a lot higher, that means they are failing. A lot of people got it wrong, because I have seen repair techs that do repairs that go ahead and say, oh, well, the capacitor measures lower, so it's going bad. No, it's actually quite the opposite. As capacitors fail, they actually go higher in capacity, and then that's when they actually fail. So watch out for that. And of course, I'm going to go and replace them all. And I'll go and show you what a good one, or not a good one, but I'll say an okay one test like here. So I got another one, same capacitor. All right, so we're going to hook that up there. Let me get the leads attached to it. Make sure it's not shorted. Let's see what the ESR meter says about the decent one. Oh yeah, it's measuring higher ESR too, but it's measuring at least lower capacity. So, but either way it goes, they are starting to fail, so they're all coming out. And what I'm gonna do as replacements is I'm gonna put these 1,000 microfarads at 35 volts. And yes, it's okay to put it on this particular switch mode power supply, but you do got to be careful when you change the value of the capacitor, because usually the higher capacity you go, and you'll get lower ripple. Like on the rail that I'm putting on, it's going to be lower ripple, but at the same time too, you can have a higher inrush current and stuff. Now these are perfectly acceptable and they'll work fine, and obviously as you can see, measuring those capacitors, they're measuring way out anyway. So either way it goes, there'll be suitable replacements for this, and I have done this on many Tektronix scopes. That's why I have these capacitors laying around, because I've done it on all the 2400 series and stuff, and they work fine, at least as far as replacing these 840 microfarad capacitors go. So I went ahead and changed these 6 capacitors right here, because they are tested either higher than normal ESR, and these are ultra low ESR capacitors. And they were testing 3 of them double the value, one 1310 and another one that was measuring 1425 microfarads when they should be measuring at 840 microfarads, and give or take 10% of that. But they're measuring a lot higher pretty much, and that's usually a sign when the capacitor is ready to fail. And if you leave it in there, it probably likely will short. So I'm glad I'm kind of went ahead and checked them out anyway, even though the scope was working fully. But went ahead and did that. I also changed the reefer caps, of course. I do gotta see about that line filter, but it's not the one that typically has the reefer caps in it. It's a different brand, so I'll look it up and see if I actually need to replace it. But other than that, I checked all these capacitors and they were bang on value. I mean, like I said, they were measuring within their capacity range, very low ESR, so there's no need to change anything that's good and that's not leaking, showing signs of failure. And one thing I want to note, and I do have to say this, do not shotgun these oscilloscopes. I've seen a lot of people do it with the 2400 series that I typically buy, because I buy a lot of them in lots. And one thing I notice is when people change the capacitors on it, they go ahead and put the wrong spec capacitors in there that are not made to work in these high frequency switch mode power supplies, and they end up blowing out the pre-regulator and causing problems and stuff like that. Don't just shotgun these. Make sure you match the data sheet with the ones that you're removing, and you get them close to spec as possible. And I use usually like my DER 5000 LCR meter to go ahead and measure it at higher frequencies, so I can make sure those capacitors will work under stress and stuff. So everything now is well within spec, at least in the power supply. I'll check the voltage rails and stuff like that to make sure that they're bang on. And then we'll go and fire up the scope and see that it actually works. So I do want to make this important message, because I know a lot of people that are probably not used to working on electronics or whatever are probably just going to go and try to replace the capacitors on their power supply by themselves. This is a high voltage power supply. I mean, this side here can deliver up to 2 kV, so you want to be very careful when working on these power supplies, especially if you're doing testing, working on it while it's live and stuff like that, because it can literally become lethal and stuff like that. So if you're not comfortable with working with mains voltage, and especially with high voltage power supply, don't mess with it, because you don't want it to hurt yourself or end up becoming lethal. So just a warning. So went ahead and put the shield back on there and stuff like that. And we're going to go ahead and test to make sure our rails are still there after servicing this power supply. So let's go and test the negative 8.6 volt rail. Yep. We'll test the positive 5 volt rail. Okay. Test the positive 8.6 volt rail. Yep. And then I believe there's another 5 volt rail right here, because there's 2 of them. Yep. Alright. And then this is the 100 volt rail right there. Yeah, we're good there. And then our 30 volt rail. Yeah, so our power supply rails are there. So that's good. So next thing is we're gonna go ahead and power it up pretty much all the way, and we're gonna see how she works. So we're gonna go ahead and test it out real quick after servicing the power supply. I still got the shielding and everything removed because I'm gonna go ahead and test for ripple and stuff like that. After I'm gonna do that off camera because that's gonna take some time. But let's go ahead and power it on and just see if it does still work. So I got line voltage on there now. And let's turn it on. Hope we don't get no magic smoke or pops or crackle. And yeah, it's a good sign. So there you go. And yeah, she still lives. So there you go. And yeah, you can see I got all the shields and stuff kind of removed on there because I do got to test the voltage on the rails and also test for ripple and stuff. But other than that, once I'm done doing that, then I'll go and put the shield back on there and I'll start servicing these switches and clean up this front plate and stuff like that. But she does still live, so that's a good sign. One thing you want to probably do is go ahead and clean the inside of where the CRT is, where the implosion shield is. And the reason why they call this implosion shield because it's in between the CRT, so the CRT were to implode, the glass shards are not going to come right at you and that will stop it. But it's also a filter too, obviously, and stuff. But you do want to take this apart, clean it with glass cleaner, get all the munked stuff out of there. Also clean this filter and implosion seal out really well. Put it back together and she'll look a lot better once it's done. So I went ahead and cleaned most of the front panel, went ahead and took this off, cleaned that as well, and also went ahead and cleaned the attenuators and the switches and everything like that, which took a good couple hours, but was well worth it. I went ahead and used pure alcohol where I could use pure alcohol and stuff like that, because you don't want to use anything pretty much else. It even says on the service manual, at least on the older scopes, don't use deoxit pretty much, but I went ahead and cleaned them up and exercised the switches and all that really good and stuff like that, and reassembled the vertical and everything like that. So that's all put back together. And I gotta say, I'm quite impressed because this scope is dead on spec. I got it at 1 megahertz, 1 volt peak to peak I'm going to be feeding on both channels. So let's just go ahead and turn it on. And there you go. I got 1 square, 1 sine wave, and I can go ahead and put channel 2 as a sine wave 2 as well. And you can see that's bang on. It's reading 1 volt peak to peak exactly on both channels, and you can see the position that I have it in. And I mean, everything works as it should, you know what I mean? When I go into different ranges, you can see there, it doesn't hesitate now that all the switches are cleaned and stuff. So this scope hopefully will work for many more years to come. It is good. I gotta go and clean the rest of the outside and stuff like that, and then I'm gonna find a spot for it so I can actually use it. And I went ahead and did test it up to 100 megahertz, and pretty much around 75 megahertz it starts to drop off, but it's well within the 3 dB mark up to a little bit over 100, and then that's when it falls off quite a bit. But quite impressed with this thing. It was sold as broken as is, but it's fully functional. Now that I went ahead and serviced the power supply and everything and cleaned all the switches and stuff like that, it works perfect actually. There's nothing wrong with it, and thankfully I don't have to do a full calibration on it, because do full calibration on these is quite lengthy and a pain in the butt, to be honest with you. But it's dead on spec, so there's no point in messing. It probably had a calibration at some point, so there you go. So went ahead and put it on channel 1 now, and let's just go ahead and see how well it does at, you know, higher frequency. So I got a 1 megahertz right now, which you can see, of course, the time base I'm in right now. Alright, so we're going to go ahead and go 5 megahertz. We'll just see frequency 5. And you can see, it's still pretty bang on. Okay. And then we'll go ahead and do a ton. Alright, we're going to go ahead and do 10 megahertz. And then, of course, we'll go ahead and hit the mag, and then we'll do 15 megahertz. Okay. And then here you go. And we'll do square. Alright, and then we'll go ahead and do 20 megahertz. And there you go, there's your square wave. And still looking pretty good actually, so yeah, quite happy with the results on this. And then we'll go back to sine wave there. And of course you can adjust right there. And you can see there, looks pretty clean, so. And it's still measuring bang on 1 volt peak to peak, so there you go.